So this is page 9 of the communication notes, and we're going to apply some of these equations now. So let's look at an example where we have the producer-consumer kind of setup where we've got a buffer. For now, let's assume that it's an infinite length buffer. So let's just say that data is produced at the arrival rate of 4 packets per second. So a packet fills a buffer. And likewise, data is consumed at, and remember, mu needs to exceed lambda is the service rate. Mu is the service rate. If our system is not going to just fill up. So let's make it 5 packets per second. And so question 1 is calculate the average number of buffered packets. So we have a buffer, let's assume it's infinite for now, unbounded. So we need to choose one of our equations. The one that has to do with the number of clients in the system was L. And L, if you look back, is equal to rho over 1 minus rho. And rho in this case is lambda over mu, 4 over 5. So we've got 4 over 5 or 1 minus 4 over 5, which is 4 over 5 over 1 over 5. So you got 4 over 5 times 5, and it all works out nicely to 4. Now, this number is the packets in the system, but remember that includes the ones waiting in the queue plus the one being served. And the question was, how many do we have buffered? So therefore the average number buffered equals L minus 1 equals 3. Okay, next question. How long on average does a packet spend in the system? So it's produced, how long until it's done being consumed? And for that we need W, which is kind of like the wait time, I guess. And the equation for that was 1 over mu, which is the service rate, over 1 minus rho, the load factor. So we've got 1 over 5 over 1 minus 4 over 5. So we've got 1/5 divided by 1/5. So it's equal to 1. Now the units for lambda and mu were packets per second, so this is going to be seconds. Okay, question 3. What's the probability the server is idle? And it's idle if there's nobody in the system, so that's the probability of 0 packets in the system, which is an easy one. 1 minus rho equals 1 minus 4 over 5 equals 20%. Alright. Question 4. What's the probability of 4 packets in the system? So that would be 3 in the buffer plus 1 being served. So probability of having 4 rho to the power 4 times the probability of 0, and so that's equal to 4/5 to the power of 4 times, remember P0 is 1 minus rho, or 4/5. If you calculate that out, you get 0.08192, or 8.192%. So that's the probability that you have exactly 4 packets in the system. And another question, which I'm going to leave to you to work out, is what's the probability of less than or equal to 4 packets in the system. That's going to be the big hint here is that it's going to be the probability of 0 plus the probability of 1 up to the probability of 4. I mean, that's giving you the answer really, but anyway.